Hello everyone, welcome to the Linux Int YouTube channel. In today's video, we are gonna talk about Python NumPy. These are today's points of discussion. So first of all, let's discuss that what Python NumPy is. NumPy is a Python library which stands for Numerical Python. It consists of multi-dimensional array objects and a collection of functions for processing these arrays. It allows us to create multi-dimensional array and we can perform complex numerical operations on these arrays. It is the core library used in scientific computing with functions that are used for linear algebraic operations and statistical operations. These are the key features of the NumPy library. We can create n-dimensional array objects by using NumPy. We can perform mathematical and logical operations on arrays by using the NumPy. We can perform operations related to linear algebra, like we can find rank of an array, we can find determinant of a matrix, we can solve linear or tensor equations, and much more. NumPy has inbuilt functions for linear algebra and random number generation, because some of the mathematical functions take random number as an input and generate the output. It usually happens when we simulate a real life scenario or mathematical scenarios. So linear algebra function and random function is a key feature of NumPy library. We can integrate the C and C++ code by using NumPy. NumPy is often used along with packages like Scientific Python and Matplotlib. This combination is widely used as a replacement for MATLAB, which is a popular platform for technical computing. So by using NumPy, we can do computation and plot data by using Matplotlib. Now let's proceed to the installation procedure, that how we can install NumPy on Linux system. This is my Linux Mint system and we can install NumPy by using Python pip. So first of all, fire up the terminal. If Python pip is not installed in your system, then run following command to install Python pip, and the command is sudo apt-get install python-pip. So system is prompting for the password, and enter your password here. Alright. Now run the following command to install NumPy by using Python pip, and the command is pip install NumPy. The NumPy library is already installed on my system, and if you are installing it for the first time, then it will take a couple of minutes. We can also use conda to install this package with the following command. Right here, conda install -c anaconda NumPy. These commands are available in the description of this video, so you can copy and paste from there. Hit enter. Press Y here to continue this installation process and hit enter. The installation is complete, and this is how you can install NumPy by using pip and conda distribution. Now let's move to our next point of today's discussion, which is getting started with the examples. This is the Python IDLE editor, and I am importing NumPy library here to use its functions. Import NumPy as np. Let's declare a simple array using NumPy. A is equal to np.array. Insert the items here like 1, 2, 3, 4. Now print this array, and we have 1, 2, 3, 4 here. It has basically printed the array that we have created. We can also create multi-dimensional arrays in this way, so let's create a multi-dimensional array. Declare the multi-dimensional array object here, and I'm gonna name it md_array equal to np.array. So now enter the items here 1, 2, 3, and 4, and the second dimension is gonna be 5, 6, 7, and 8. Now let's print this array md_array NumPy array can be used in any dimensional space to hold data, so we can find the dimension of an array. To find the dimension, right here print dimension is right here the name of the array, that is md_array dot, and it will calculate the dimension of the array. It has printed 2, it means that we have two-dimensional array here. Similarly, we can find out the data type of the data. Right here print md_array, which is the name of our array, and call here the function dtype. Performing the mathematical operations on items of an array is very simple, and we can easily find out the maximum, minimum and sum of all items of the array. So let's do it, and right here print, and if we want to find out the maximum number in the array, so right here the maximum is md_array dot max, and the maximum number is 8. To find out the minimum number, right here print md_array dot min. The minimum number is 1, and similarly we can find the sum of all the items of an array. So for this purpose, right here print the sum is md_array dot sum. So basically it has added all the items of the array and it has returned the sum, that is 36. To find out the mean of the array, right here print md_array dot mean, and the mean is 4.5. If we have been using Python list in our existing programs and we don't want to change all the code but still want to make use of NumPy arrays, so we can easily convert a Python list to a NumPy array. Let's make two lists for height and weight. Now let's create two NumPy arrays from height and weight. Right here the name of the array, and I'm gonna write here np_height, that is equal to np.array, and inside these brackets we have to write the name of the list, that is height, and create an array for the weight list, np_weight, that is equal to np.array, and write down the name of the list here, that is weight, and hit enter. Now let's print it, np_height. I have cleared the shell of IDLE editor. If we have a NumPy array that is consist of 2 rows and 4 columns like this, it can be reshaped to contain 4 rows and 2 columns. So let's write a simple code to reshape this array. Write the name of the new array here, that is reshaped array, and now write the name of the existing array, that is original dot reshape. So first of all, write here the number of rows that you want to create, and write here 4, and write here the number of columns, that is 2. Let me just print the original and reshaped array to see the difference. Print so that is the original array, and now print the reshaped array, that is reshaped, hit enter, and here we can see that now it has 4 rows. Now let's see a couple of examples of linear algebra module of NumPy. So declare a 3-dimensional array here, and let me name it matrix. By using the linear algebraic functions, we can compute the rank of a matrix. Right here print, and right here rank is np.linear algebra dot matrix rank. Now write here the name of the matrix, and the name is matrix, and hit enter, and it has printed the rank, that is 2. To compute the trace of a matrix, write here print np.trace, and inside this bracket write the name of the matrix and hit enter, and the trace is 15. Similarly, we can compute the determinant of a matrix. So write here print np.linearalgebra.det and the name of the matrix. To compute the inverse of a matrix, write here print np.linearalgebra.inverse, that is the function to compute the inverse of a matrix, and write here the name and hit enter. So this is the inverse of the matrix, it has printed here. We can compute the transpose of matrix by using Numpy, and it is very simple. Write here print matrix dot transpose. That's it for today's video. I hope you found this video useful to learn about Python Numpy. Keep following us on Linux Int YouTube channel, and don't forget to subscribe it for more useful videos. Thank you.